Imagine if a car could hover around the city like in the movies. That's cool, right? What if I told you that might be possible with the concept of quantum locking? Well, a car hovering around the city might be possible with magnetic tracks, but the process might be very complicated. Let me explain. Let's take a trip to quantum mechanics. Quantum locking is a phenomenon where a magnet levitates a superconductor. A material is a superconductor if it repels magnetic field due to the Meissner effect. This means small currents flow in the superconductor with no resistance that make an opposite magnetic field that repels the field of the magnet. This happens when a superconductor is in a critical temperature, which means the conductor wouldn't lose energy simply because it will have zero resistance considering its temperature. Since electrons will flow into the conductor without colliding with atoms, because the collision of atoms is the cause of heat, which will be resistance. But why doesn't the superconductor slip when it's levitated? And does it stay in its place? Flux spinning. Well, magnetic field can still be able to penetrate the Meissner effect, varying to the thickness of the superconductor. These are called flux lines. Flux lines are the number of magnetic field passing through a material. As for the Meissner effect to happen, the superconductor surface must be smooth, but in some cases, there are areas of the material a little bit thicker or thinner. The superconductor impurities acts as weak points or flux tubes for the flux lines to pass through. So, these flux lines that penetrate the Meissner effect will stabilize the position of the superconductor, and a flux tube generally means an area of space through which a strong magnetic field passes through. So, the state where the superconductor repels magnetic field is the Meissner effect, and quantum locking occurs when the superconductor is trapped within a magnetic field. And when this happens, the superconductor won't move without an outside force.